All right, so this is the first of just a few lessons in which we start to look at trigonometry a little bit differently, and we start to apply these ideas to rotations instead of triangles. Essentially, all the basics of trigonometry with regards to triangles we've now kind of covered. But we start to introduce trigonometry in a different way, which is really a lead-in to a huge part of Pre-Calculus 12, which is when you really look at this in detail. And so what I have here is what we call an angle in standard position. So what you see right here is a rotating arm in blue. And I can rotate it in either direction. The vertical and horizontal black lines you see are meant to be the x and y axis. So I have the x-axis and the y-axis. And this rotation is rotating around the point 0, 0. We call that the axis of rotation. And you may as well notice, maybe it's a little tough to see, but there's a red line right on the x-axis. That's what we call the initial arm. So the idea is this rotation I have here started at this point on the initial arm, and it rotated either this direction or it can rotate this direction. And so if I just stop rotating it, I don't know, there. So what you're seeing now is where the terminal arm ended. And so a few more things. When a rotation goes this direction, and it can go around and around, we call this a positive angle. So whatever angle this is a positive number. When a rotation goes this direction, it's a negative angle. So for example, this from here to here, this is about positive 45 degrees. This is positive 90 degrees. This is positive 180 degrees, and so on. If I go backwards, this is negative 45. This is negative 90, negative 180, and so on. And once we think about angles as rotations, then there's no limit to what the angle can be. There's no maximum rotation. There's no minimum rotation. You can go around more than once. You can go backwards around more than once. All right, so what I have there, I want to now start kind of formalizing these things in our notes right here. So an angle in standard position is, again, showing a rotation, a standard way of showing a rotation on the coordinate plane, in which the rotation is always by convention. This, again, this is a standard way of showing it. Begins where that red arrow was just drawn, and we call that the initial arm. And it ends somewhere else. And so I'll draw, I don't know, another arm right here, and we call that the terminal arm. And if you just look at this where it started and it ended, you may visualize a rotation like this. Although, to be honest, if I didn't show you that arrow, how do you know it didn't go backwards? We didn't. But let's, for simplicity's sake, show that. And that angle there, we usually use a variable theta. We've seen that before. And so here's an example of an angle in standard position, which ends, I'd say this angle is roughly 120, 130 degrees or so, something like that. As well, since we are dealing with an angle being shown on an xy coordinate plane, we have quadrants. And again, this is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Again, any two-dimensional graph drawn on the xy coordinate plane, any plane, any xy coordinate plane breaks an image up, a graph up into 4 quadrants. All right, so with that said, let's have a few examples of some different angles in standard position. So for example, let's visualize a few different things here. So if I want to visualize an 80-degree angle in standard position, then the way I visualize that is it always starts right here. That's the convention, the standard. 80 degrees is just shy of 90 degrees, so something like that. And I should always show the rotation. So from there to there. There we go. That's my sketch for an 80-degree angle in standard position. What if I wanted to show a 200-degree angle in standard position? Well, again, they always start at the same spot. That's the standard. But 200 degrees, if it's positive 200, will go more than this. This is 180, so about 20 degrees extra. I don't know, maybe to about there, let's say. And that's my sketch of a 200-degree angle in standard position. What if I had a negative 200-degree angle? What if theta was negative 200 degrees? Well, again, doesn't affect where it starts. But this time I want to rotate the other direction, so I want to go backwards. This is negative 90, this is negative 180, so a little bit more, something like that. That is representing negative 200 degrees. And I'll do one more example. What if I have something fairly large, like 430 degrees? Well, that's more than one full rotation all the way around. It still starts at the same spot, so it starts right there. It's a positive angle, so it's going this way. But I'm going all the way around. That's 360. And so I need to go to get the 430. I need to get an extra 70 degrees. So, oh, why did he vanish on me? So, oh, because I grabbed an eraser. There we go. To about there, let's say. So there's my sketch of 430 degrees in standard position. Now, if I zoom in on this little angle, this little extra 70 degree angle I drew right here, that's called the reference angle. What I sketched out was a 430 degree angle, but that 70 degrees was a natural thing for me to think about. That was the extra little bit that I needed to visualize to kind of finish off my rotation. And we'll hear about that phrase, reference angle, soon enough, again, more formally. And so, if the angles are a bit more messy, that doesn't really make much of a difference. In which quadrant does the terminal arm of each angle in standard position lie? Well, for 174 degrees, I know that must be quadrant 2. And I know that because 174 is just shy of 180. And I know that from here to here is 180 degrees. So this must be just a little bit less. So it must be something like that. In fact, even closer. It doesn't matter, though. I've answered the question already. It's in quadrant 2. 288 degrees, I know must be in quadrant 4. And I know that, again, from a quick little visualization. This time, I know that that's 90, that's 180. Add another 90, this is 270. And so 288 degrees is a little bit beyond 270. So it's something like this, let's say. Either way, that's in quadrant 4. All right, so now let me formally introduce this reference angle, which I mentioned once before. The reference angle is always acute, and it's the angle between the terminal arm and the x-axis, and it's always acute. It's always less than 90 degrees. So for example, here's an angle in standard position. And again, you could visualize it getting there like this. You could visualize it getting there like this. You could visualize it going around backwards once, twice, whatever. There's lots of ways. But again, it doesn't matter. The reference angle is the angle formed between the terminal arm and the x-axis. So it must be this angle right here. If you thought of this angle right here, that's not an acute angle. If you thought of this angle right here, that's between the y-axis and the terminal arm. So it's that angle right there, and that's the reference angle. And usually I just denote it with a theta and an r. And so, I'll say this reference angle looks to be about 40 degrees. Just kind of estimating what it is. And so looking at this angle here, okay, the reference angle, again, is the angle between the terminal arm and the x-axis. So it has to be this angle right here. And in this case, it looks a little bit more than 45 degrees because that angle, that rotation from there to there is definitely less than that rotation from there to there. And so I'll say, I don't know, let's say 50 degrees. And again, I'm just estimating here. But again, the reference angle is always acute. It's always, which means it's never more than 90 degrees, and it's always between the x-axis and the terminal arm. So what if I give you an angle as a value? What's the reference angle? Well, let's say I have a 75 degree angle. What's the reference angle? Well, the reference angle is 75 degrees. How do I know that? Well, let's visualize a 75 degree angle in standard position. Again, always starts right here. 75 degrees, it's a positive number, so something like that. That's 75 degrees. The reference angle is the angle from here to here, which again must be 75 degrees. And so in general, if you're looking at an angle in standard position that's between 0 and 90, the reference angle is the exact same thing. But what about the next one, 240 degrees? Well, let's visualize that. 240 degrees. Positive angle. This is positive 90, positive 180. This is positive 270, so that's too much. So it must be something like this. So that's the quadrant it's in. But what's the reference angle? Well, the reference angle is this angle from here to here. And again, if I know that whole rotation is 240 degrees, and I know from here to here is 180, that reference angle must be the difference between 240 and 180, which is 60 degrees. And so this reference angle, again, is 60 degrees. And that phrase, reference angle, we're going to start hearing about a lot, especially in Pre-Calculus 12. And so, before a final problem, one more quick question. And notice everything's actually been really, really quick in this lesson. Name 4 angles that have a reference angle of 40 degrees. And I will say there's a lot more than 4 possible answers. I just want 4. So what I'd recommend is, making a little visual. If an angle in standard position has a reference angle of 40 degrees, well, they all start right there. But if the reference angle is 40 degrees, that means the angle between the terminal arm and the x-axis must be 40 degrees. So one possibility is if the angle is 40 degrees, like that. But another possibility is if we're like right here, or right here, or right here. All of these angles I can visualize could have a reference angle of 40 degrees. So what are the angles? Well, from here to here, that is 40 degrees. That's one possibility. Another one from here to here, what's that angle? It's 180 minus the reference angle. It's 180 minus that 40. Because again, from here to here is 180, but I'm 40 degrees short of that. So that's 140 degrees. That also has a reference angle of 40 degrees. What about this angle from here to here? That's 180 plus 40, so 220 degrees. And finally, what about this angle all the way to here? That's almost all the way around, so it's almost 360 degrees, but it's 40 degrees short of that, so it's 360 minus 40, which is 320 degrees. I'm going to go dot, dot, dot on either way, because, like I said, these are not the only possibilities. These are the most kind of straightforward ones. But like I said, I could also go backwards, negative 40. All these negative angles, I'm just sketching out, all have a reference angle of 40. There's an infinite number of correct answers to this. But the 4 that I labeled initially, and I'll just keep there, those are the most, I think, straightforward ones. All right, so final problem. Once again, I have an angle in standard position. And I'm telling you the terminal arm goes through the point negative root 3, comma, negative 1. So that's describing a point on this terminal arm. So if I look at this terminal arm, I'll just put a point on it, and I know it goes through negative root 3, comma, negative 1. Okay. So what is the angle of rotation? What is theta? And again, if I look at this, I could think of theta being like this, and I'll stick with that. Although, again, it could be going like this, so there's more than one possible answer to this. But I'll stick with what I think is the most straightforward. So what's that angle? Okay, well, how can I figure this out? Well, let's zoom in on this. One thing I could do is there's no triangles here, I could create a triangle. If I draw a vertical line up there, I have a right triangle. And this x-coordinate of root 3 is kind of equivalent to the distance from there to there. So I could say that distance is root 3. And this y-coordinate of negative 1 is kind of equivalent to this vertical distance right here, which I could say is just a distance of 1. I know the x and y coordinates are negative. That tells me the direction, but the distance is always a positive number. And so if I do that, hopefully this triangle looks familiar, because this triangle here has the makings of one of our special triangles that we reviewed at the beginning of this unit. And so, and again, this all comes from memory. But anytime, if I look at this, if I put a 2 right there, I have, again, one of our special triangles. We have our 30, 60, 90 degree special triangle, which means I now know this angle from here to here is 30 degrees, which means I know this total angle here must be 180 plus 30, so I know theta must be, or one possibility for theta is that this is 210 degrees. And notice I got that answer without actually performing any more complex calculations than 180 plus 30. But that relied on me knowing my special triangles. What if I didn't recognize this as a special triangle? What if I just go back to this? Okay, I'm still not stuck. I could then use some trigonometry because I do have a right triangle. And I have a right triangle in which I know two of the sides. And so if I want to figure out this angle right here, this reference angle, because if I can figure out that reference angle right there, then I know I can just add it to 180. And so if I didn't recognize a special triangle right away, I could use the tangent ratio, because I can say the tangent of my reference angle must equal opposite 1 over adjacent, root 3. And at this point, how could I find the reference angle? I could go to my calculator and use the inverse tan of 1 divided by the square root of 3. Or I could think back to my special triangle. And again, if I could think back to that 30, 60, 90 special triangle, 30, 60, 90, 2, 1, root 3. And so this here really means, where does tangent equal 1 over root 3? What angle does tangent equal 1 over root 3? Well, from 30 degrees, tangent is opposite over adjacent. So 30 degrees must be the answer for the reference angle. That's without a calculator. But again, you could also just use a calculator. Type in inverse tan of 1 over root 3, and you get 30 degrees. But again, that's my reference angle. And so that there tells me that angle there, which led me to that. And so now I'm basically kind of 3 different ways I've worked out this problem. 2 of which didn't involve a calculator. I kind of like the first one the best, but that relied on us remembering our special triangles. But we were introduced to those in the first lesson for a reason. But even without that, we could get to that answer. And so finally, because we haven't really used special triangles in a bit, let me just go back to the trigonometry review. And so if I look back at this lesson right here, this was the part where I'm talking about our special triangles. And in this case, I was using this triangle right here, the 60, 90, 30 triangle. All right. So with that said, this is the introduction to a really important part of trigonometry that we just kind of go over a little bit in pre-calculus 11. Becomes a huge part of pre-calculus 12. But I'm going to stop there.